Hi. So for my data communications laboratory subject, this is experiment 4 entitled Use Wireshark to View Network Traffic. So for the topology, this is the internet. It is connected to our router. Our router is our default gateway to connect electronic devices to the internet using the local area network, then connected to the router, then the internet. So for the objectives of this experiment is to capture and analyze local ICMP data in Wireshark and to capture and analyze remote ICMP data in Wireshark. For a short background and scenario, Wireshark is a software protocol analyzer or packet sniffer application used for network troubleshooting, analysis, software and protocol development, and education. As data streams travel back and forth over the network, the sniffer captures each protocol data unit or PDU and can decode and analyze its content according to the appropriate RFC or other specifications. Wireshark is a useful tool for anyone working with networks and can be used with most labs in the CCNA courses for data analysis and troubleshooting. In this lab, you will use Wireshark to capture ICMP data packet IP addresses and Ethernet frame MAC addresses. So required resources for this experiment is one PC that should be Windows with internet access, an additional PC that is connected on the same local area network as your PC to be used to reply to ping requests. So for the instructions of this experiment, part 1, capture and analyze local ICMP data in Wireshark. In this part of this lab, you will ping another PC on the LAN and capture ICMP requests and replies in Wireshark. You will also look inside the frames captured for specific information. This analysis should help to clarify how packet headers are used to transport data to their destination. So for step 1, retrieve your PC interface addresses. For this lab, you will need to retrieve your PC IP address and its network interference card or NIC physical address, also called as MAC address. So to do that, we need to open command prompt window and enter this to our command prompt. So let's open command prompt and let's type IP config \all, and as you can see here, these are all of our information in our IP configuration. So here you can observe that we have a physical address of 44-01-BB-9F-93-7E, and also MAC address is 192.168.100.1. There. B, for step 1, ask a team member or team members for their PC IP address and provide your PC IP address to them. Do not provide them with your MAC address at this time. So here, since we're not in face-to-face classes, I'll just use another laptop here in our home. So here's the screenshot of my other laptop. So as you can observe, it also has the same MAC address as to my PC here, since I'm using the same network. So it also has 192.168.100.1. So next, step 2, start Wireshark and begin capturing data. So navigate to Wireshark. Let's do that. There. So next, double click the desired interface to start the packet capture. So since my PC is using a Wi-Fi adapter and not an Ethernet LAN cable, you can observe that there's only traffic here in my Wi-Fi. So I am going to select this. So as we select, we can observe that there is traffic in our Wi-Fi. So the information is scrolling down from the top section in Wireshark. This means that data traffic is happening. So we can also observe that data lines appear in different colors based on their protocol. So this information can scroll by very quickly depending on what communication is taking place between your PC and the LAN. We can apply a filter to make it easier to view and work with the data that is being captured by Wireshark. So to apply a filter, we click on apply a display filter here and type ICMP. So as we can observe, the filter causes all the data in the top window to disappear, but this still captures the traffic in our on the interface. So what we need to do next is navigate to a command prompt window and ping the IP address that you receive from your team member, or in my case from my other laptop. So here's the picture again of the network in my MacBook. So it has a ping of 192.168.100.12. So what we need to do is ping that in our command prompt window and type ping space 192.168.100.12. There. So here, upon pinging the IP address of my other device, here in my PC, we had a data traffic here in the top section of our Wireshark. We can observe the request and reply traffic here. So step 3, examine the captured data. In step 3, the data that was generated by ping request of this PC to my other device, Wireshark data is displayed in three sections. The top section displays the list of PDU frames captured with a summary of the IP packet information listed. So this section here is the display of the list of PDU frames. So as we can observe, here is the source, the destination, the protocol, and also what is happening or the information here. And next, this is the middle section, which is the PDU information for the frame selected in the top part of the screen. So here I selected this is selected, so this is the PDU information on this frame. So it separates a captured PDU frame by its protocol layers. There. And at the bottom section displays the raw data of each layer. The raw data is displayed in both hexadecimal and decimal form. So here is the part where it's hexadecimal and decimal form. Next step, click the first ICMP request PDU frame in the top section of Wireshark, this one. Notice that the source column has your PC IP address. There, 192.168.100.12. And the destination column contains the IP address of your teammate PC that you ping. So next, click the first ICMP request PDU frame in the top section of Wireshark. So this first frame here. And as we can observe that from our source, it has the same PC IP address as for my PC here that I'm using. And our destination is the same with my other device's network IP PC IP address. So this PC here is 192.168.100.150, and my other device or my MacBook is 192.168.100.12. So with this PDU frame still selected in the top section, navigate to the middle section, click the plus sign to the left of the Ethernet row to view the destination and source MAC address. So let's do that. Does the source MAC address match your PC interface? So here, this is our source. So from what we can recall here, if we can it has the same source. So this is our physical address 4401BB9F937E, and it's the same here in our source. Does the destination MAC address in Wireshark match your team member MAC address? There, this is our MAC address. You can observe that it has the same 1094BBE7454C. How is the MAC address of the pinged PC obtained by your PC? The MAC address of my PC. How is the MAC address of the pinged PC obtained by your PC? The MAC address of my MacBook was obtained by my PC since it is connected with the same IP address, which is 192.168.100.1. So for part 2, capture and analyze remote IC MP data in Wireshark. So for this, we need to ping remote hosts, not hosts that are not in our local area network or our devices connected to the same routers, and examine the generated data from those pings. You will then determine what is different about this data from the data examined in part 1. So to do this, we need to start data capture again. Let's open Wireshark. So now that we have Wireshark here, a window prompts you to save the previously captured data, but we would not be using this since I closed it already earlier. So now let's just click on Wi-Fi here and ICMP to filter it out, and using our command prompt, let's ping these websites. So let's ping www.yahoo.com. So now you can observe that it's pinging with an IP address of 202.165.107.49. Now let's ping CISCO, www.cisco.com. You can observe here in our Wireshark the traffic, and here we can observe the IP address of 23.74.241.21. Request timed out here, maybe because of my internet connection. So ping last www.google.com. So as you can observe, the Wireshark shows the request and reply data, traffic data. We can observe that Google has an IP address of 142.250.66.100. Now, note when you ping, notice that the DNS translates to the URL to an IP address. Note the IP address received for each URL. So let's note this for Yahoo. We have an IP of this, and this is for Cisco, and this is for Google. There. You can stop capturing data by clicking Stop Capture. Now, review the captured data in Wireshark and examine the IP and MAC address of the 3 locations that you pinged. List the destination IP and MAC address for all 3 locations in the space provided. So, with our ping as 202.165.107, this is Yahoo. So let's check on its source. The IP address rather is this one, and the MAC address for Yahoo is this. for CISCO. And the ping address for Google. There. So here, what is significant about this information? We can observe that the destination of the MAC address for 3 locations are the same. So here. And how does this information differ from the local ping information you receive in part 1? So in part 1, this is for the local hosts, and now we are experimenting remote host. So pinging a local host returns the MAC addresses, which explains the same MAC address value. In part 1, the destination address is the same with the MAC address that we have in my second device or my laptop. On the other hand, pinging remote host will return the MAC address of the default gateway router, then the router will be pinging the asked remote host. So reflection question: why does Wireshark show the actual MAC address of the local host but not the actual MAC address for the remote host? This is because the local area network or LAN only knows the MAC address for local host and not remote host. In terms of remote host, the MAC address of the default gateway router will be used. The MAC address will be different once it reaches the MAC address of the website URL. This is because it is stripped in the router or our default gateway router to be able to find the MAC address of each URL. So part 1, create a new inbound rule allowing ICMP traffic through the firewall. So navigate through control panel, system and security, Windows Defender, firewall. Now click on advanced settings. On the advanced setting, on the advanced security window, click the inbound rules option on the left side, then click new rule. Click custom. In the left pane, click protocol and ports. Protocol type, select ICMPv4 and click next. Now verify that any IP address for both local and remote IP addresses are selected. Click next to continue. Select allow the connection. Continue. By default, this will apply to all profiles. Click continue. Name the rule. Allow ICMP requests. Click finish to continue. Next, part 2, disabling or deleting the new ICMP rule. After the lab is completed, you may want to disable or even delete the new rule you created in step 1. Using the disable rule option allows you to enable the rule again at a later date. Deleting the rule permanently deletes it from the list of inbound rules. On the advanced security window, click inbound rules in the left pane and then locate the rule you created previously and select disable rule if desired. You may also select delete if you want to delete it permanently. If you just do this option, you must create a new rule again to allow ICMP replies. So for now, I will just be disabling it, and when I need it, I will enable it here in the Windows Defender Firewall Advanced Security. So I think that's it for the end of our experiment 4. Use Wireshark to view network traffic. Thank you.